Hello everyone, I am Saumesh Rekes, Assistant Professor, Department of EEE, ATMECE. I welcome students of EEE to the demonstration sessions of the experiments in the Electric Motors Laboratory. And the course code of this laboratory is BEEL 404. Today we are going to demonstrate the experiment load test on DC shunt motor to draw speed, torque and horsepower efficiency characteristics. Let us move on to the learning objectives of this experiment. To obtain speed torque characteristics of DC shunt motor, to obtain horsepower efficiency characteristics of DC shunt motor. The nameplate details of the DC shunt motor which we are using to demonstrate the load test on DC shunt motor is: the armature voltage is 220 volt and the armature current is 12 amperes. The field voltage is 220 volts and the field current is 0.8 amperes. And the rated speed of the DC shunt motor is 1500 rpm. To conduct this experiment, we require the below apparatus. From the nameplate details, we can decide the apparatus required to conduct this experiment. As we all know that the rated current of the DC shunt motor which we are using to conduct this experiment is 12 amperes. Hence, we have choose the moving coil ammeter A1, that is 0 to 220 amperes, and the field current is 0.8 amperes. So we have chosen here moving coil ammeter A2, that is of 0 to 2 amperes, and the moving coil voltmeter is 300 volt, and the field rheostat is 0 to 600 ohm and 2 amperes. And this is the connection diagram, that is circuit diagram. This is the 220 volt supply which is having the positive polarity and the negative polarity, where this is a 3-point starter. L indicates line, F indicates field, and the A indicates the armature. As you observe here, we have here DPST or the MCB switch, that is double pole single throw switch or the miniature circuit breaker. Through this, we have connected to the entire circuit to the DC supply. As you observe here, ammeter A1 is connected to the positive supply of the DC. That is, it is going to measure the total current, that is incoming current, and the negative of the ammeter is connected to the line of the 3-point starter, and F, that is F field of the 3-point starter, is connected to the ammeter A2. Through this, negative terminal of ammeter is connected to a rheostat. Remember, the field rheostat should be placed in the cut out position, and another terminal of the field rheostat is connected to the field winding of the motor, that is F, where FF is connected either to the armature, that is AA, or to the supply voltage, that is negative supply voltage. And A, that is armature from the 3-point starter, is connected to the A, that is armature of the motor, armature winding, and AA either connected to FF or connected back to the DC supply. In order to load the DC shunt motor, a brake drum is mechanically coupled with it via spring balance setup. By adjusting the spring balance, the load is applied gradually. This is the procedure. Connections are made as shown in the circuit diagram. Make sure that the field rheostat is kept in the cutout position. Close the supply switch and start the DC motor using a 3-point starter. Cut in the motor field rheostat slowly until the motor reaches the rated speed, that is 1500 rpm. Note down the no-load readings of all the meters. Now load the motor in steps nearly to its rated current. For each loading, all the meter readings and speed of the motor are tabulated. Release all the loads. Reduce the speed of the motor by making the field rheostat to cutout position and open the supply switch. Shaft torque, brake horsepower and efficiency of the motor are calculated. The graph of percentage versus VHP and speed versus torque is plotted. And this is the tabular column where from the voltmeter we are going to record the voltage readings, and from the ammeter we are going to record the current, and where S1 and S2 is nothing but the mechanical loading where S is nothing but the difference between S1 and S2. TSH, that is a shaft torque, which is nothing but 9.81 into S, and the R, where R is the radius of the brake drum, and N is the speed. For every load we need to record the speed also, and the motor output is nothing but the shaft torque into 2 pi into speed of the armature divided by 60. BHP is equals to output by 746, and the percentage efficiency is nothing but output by input into 100. So where motor input is nothing but V into I in watts, motor output is TSH into 2 pi n by 60 watts. BHP equals motor output by 746. Motor torque is 9.81 into S into R. Efficiency is output by input into 100. With the help of those calculations, we can plot the graph of torque versus speed and the efficiency versus BHP. Since it is a DC shunt motor, even though the torque increases, the speed will be slightly decreases. And when it comes to efficiency versus BHP, as the output power increases, to some extent, the efficiency also increases whenever a constant losses is equals to the copper losses. We will attain a maximum efficiency. Further, if you increases the output power, the efficiency will start decreases.
Load test on DC shunt motor. Connections are made as shown in the circuit diagram. Make sure that the field rheostat should be kept in cutout position. Close the supply switch and start the DC motor using a 3-point starter. Cut in the motor field rheostat slowly until the motor reaches the rated speed. Note down the initial readings of all the meter and also the speed of the DC motor. Now load the motor in steps nearly to its rated current. For each loading, all the meter readings and speed of the motor are tabulated. Release all the loads. Reduce the speed of the motor by making RFM to cutout position and open the supply switch.